Hello friends, welcome to the next session under divide and conquer approach. Today we'll look at another example on divide and conquer approach, that is quick sort, one of the most popular sorting algorithm, right? So here quick sort, even it is called as partition sort or partition and swap sort. Though the name is quick, in the worst case, the complexity is still big O of n square, right? But it is better than bubble sort, insertion sort, selection sort. So let us look at. And again, when we are talking about quick sort as a divide and conquer approach algorithm, then by default, you can write it in a recursive way, right? So let us look at quick sort. So it's a divide and conquer algorithm. It creates two empty arrays to hold elements less than the pivot value and the elements greater than the pivot value, and then recursively sort the sub arrays. So the two basic operations in the algorithm is swapping items in place and partitioning a section of the array. So the concept is, in short, the concept is what? You are given a list of items or the numbers or the keys, right? You select one of them as a pivot. Pivot is a main value because at the end of first iteration, this pivot will be placed at its right position. That means all the values on the left side of the pivot will be smaller than the pivot, and all the values on the right side will be greater than the pivot, right? So once the pivot is placed at the right position, it will again partition the list into two sub arrays, right? Or two sub lists. Again, the same process will be applying on those sub arrays. So let us look at the algorithm and then we'll have an example so the concept will be more clear. So the very first thing what you need to do is find a pivot item in the array, and this item is the basis for comparison for a single round, that is for single iteration, right? Now start a pointer. So here we'll be having a start pointer at the first item in the array. So you'll have a pointer which will point to the first item in the array. Start a pointer, that is the end pointer, and that will be pointing at the last item of the array. So you'll have two pointers, start pointer and the end pointer. Start pointer pointing to the first item in the array and the last pointer pointing to the end pointer pointing to the last item in the array. Well, the value at the start pointer in the array is less than or equal to the pivot value, move the start pointer to the right. So every time we'll be comparing the value of start pointer with the pivot. If the value of start pointer is less than or equal to pivot, then you will be incrementing the start pointer by 1, right? So if it is pointing at 0th position, then it will move to the first index, fine? Continue until the value at the start pointer is greater than the pivot value. So as soon as the start pointer value is greater than the pivot, you stop the increment of the start pointer, fine? Similarly, while the value at the end pointer in the array is greater than the pivot value, move the end pointer to the left. Why? That is decrement y, y1. Why? Because the end pointer is always pointing to the end of the array. So you need to decrement the end pointer so that it moves by 1 step. Continue until the value at the end pointer is less than or equal to the pivot value. So the simple condition, what you should remember is start pointer value should be less than the pivot. So the start pointer will increment. End pointer value should be greater than the pivot. So the end pointer will decrement. Like if it is at nth position, it will move to n minus 1 position. So if the start pointer is less than or equal to the end pointer, if the start pointer is less than or equal to the end pointer, then swap the values at these locations in the array, right? If it is at the same position or if it is at different position, you need to swap the values. That means it should be less than or equal to the end pointer. Now move the start pointer to the end by 1 and the end pointer to the start by 1. If the start pointer and the end pointer don't meet, go to step 1. That is, again, go back here and again start finding a new pivot and apply the same steps again. Fine. Now let us look at an example so the concept will be more clear. Now, this is the array or the list of items or the list of numbers which are given to you, right? Now we need to sort these items using quicksort algorithm. As we already saw in the algorithm, what is the first step we do? Select a pivot. So you can have the first item as pivot, you can have the last item as a pivot, you can have randomly any item as a pivot, or there is an algorithm to decide what should be the pivot, because selection of pivot plays an important role in determining the complexity of the algorithm. Fine. Now, suppose we select the first item as pivot. Now, you need to position our start pointer and the end pointer. So start pointer at the beginning of the list and end pointer at the end of the list, right? So this is a start pointer, this is end pointer. Our first item itself is our pivot element. So the start pointer is pointing to the pivot element as well as the first item in the list. Here, start and pivot are same item, right? Start and pivot. Start is pointing to the first item. The first item itself is pivot. So here pivot is equal to start. So now increment the start pointer. So increment the start pointer. So start pointer was pointing here. Now it is pointing here. Fine. Very simple. Now check the start pointer is smaller than pivot. Yes, start pointer is pointing at 2, pivot is 4, 2 is smaller than 4. So what you do again, increment the start pointer. So start pointer is pointing here now. It is pointing at 6. Again check whether the start pointer is smaller than pivot. No. Why? Because 6 is greater than 4. Start pointer value is greater than 4. So you freeze your start pointer here, right? Your start pointer will not move anywhere now. You freeze the start pointer. Now let us look at the end pointer. Now, if the element is greater than the pivot, in the end element is greater than pivot, yes. 7 is greater than 4. 7 is greater than 4. So what you do, you decrement the end pointer. So end pointer is now pointing at 9. Remember, this is incrementing, this is decrementing, right? So now end pointer is pointing at 9. Again, you check, right? Whether 9 is greater than pivot. 9 is greater than pivot. So again, what you do, decrement the end pointer. So now end pointer is pointing at 3. Again, you check whether the end pointer value is greater than 4. No. End pointer value is not greater than 4. So what you do, you freeze the end pointer, right? So that means end pointer will not move further now. Now what we do? Now we swap the values of start pointer and the end pointer because both are freezed. Now you swap the values of start pointer and end pointer. So 6 is replaced by 3 and 3 is replaced by 6. Is it fine? What we did? We swap the values of start and end pointer, right? So this is 3 now and this is 6, right? And the pointers will be incremented by 1. Right? Now, after swapping, this is the list what we have, right? Now again, start comparing it with the pivot. Now start pointer is at 3, compare it with pivot. So 3 is less than pivot. So what you do, increment your start pointer. So start pointer was pointing at 3, now it is pointing at 5. Again, compare it with pivot. Now start pointer value that is 5 is greater than pivot. So you freeze the start pointer. It will not go further. See, you move the start pointer only when it is less than or equal to pivot. Right now it is greater than pivot. So you don't increment it and you freeze the start pointer. Now let us move to the end pointer. Fine. Now check end pointer. Is it greater than pivot? Yes. 6 is greater than 4. So what you do? You decrement end pointer. So now start pointer and end pointer both are pointing at the same item, that is 5. Now again check whether your end item is greater than pivot. Yes, 5 is greater than pivot. So again decrement your end pointer. 5 is greater than 4. So your end pointer is decremented. Now it is pointing at 3 and start pointer is pointing at 5. Now again check, is the end pointer greater than pivot? No, right? Why? Because 3 is smaller than 4. So you stop now and freeze your end pointer also. Freeze your end pointer. Now start pointer has crossed the end pointer, right? That is start is greater than end now. Start position is greater than end position. So now what you do, you swap the value of end pointer with the pivot. If the start has already crossed the end pointer and both the pointers are freeze now, then you swap the value of end pointer with pivot, right? So 3 is swapped with pivot. So 3 is here now and pivot, that is 4 is here. Is it fine? Now this means 4 is our pivot element and it is reached at its right position. What does that right position means? All the items which are smaller than pivot are on the left side. All the items which are greater than pivot are on the right side. Fine. So all the items on the left side are smaller than pivot. All the items greater than pivot are on the right side. So what you did after positioning 4 at its right position, the pivot at its right position, your array or your list is divided into sub arrays, that is partitioned into P1 and P2. So array is partitioned into half, that is P1 and P2, into two parts, P1 and P2, right? P1 is a list consisting of all the items less than pivot. P2 is the list consisting of all the items greater than pivot, right? Now let us start applying the same quick sort algorithm at P1 and then at P2. So let us start with P1 again. Now we'll not touch here, this is already sorted. So this is our array to be sorted. So by default, again, as we said, you always take the first item as the pivot. So 3 is pivot now. Position your start pointer and end pointer. Start pointer is at start of the array. End pointer is at the end of the array because there are only two items in the array. So this is the start pointer. This is the end pointer. Now, as the start pointer and pivot are pointing at the same value, right? So what you do, increment start pointer. So start pointer is now pointing at 2. Fine. Why? Because start pointer value and pivot is same. So you increment your start pointer. Now check whether 2 is already. So now here pivot is equal to start. Now increment your start pointer. So you are at 2 here. Now, if you look at this, now start pointer and end pointer both are pointing at the same item, right? So what you do, as I already said in the algorithm, when both are pointing at the same item, you stop and you swap the value of the end pointer with the pivot. End pointer with the pivot. So both the pointers are freezed, right? And the pivot value is swapped with the end pointer value. So these two are swapped now. 3 is here, 2 is here. That means your 3 is at its right position. Fine. Now, what is remaining here is only one item, that is 2, which cannot be sorted. It's an atomic item. So this by default is sorted. So now you already got the array which has 2, 3, and 4 at its position. 2, 3, and 4. So this part of the array or the list is sorted. Right. Now this part is, now what is remaining? Now this partition P2 is remaining with 5, 6, 9, 7 to be sorted. So again, we select this side of the array or the list to be sorted. Now we select the pivot for P2, partition P2. So here by default, the first item we take as pivot. So start pointer is pointing to pivot, end pointer is pointing to the end of this subarray. Fine. Now again, the same thing. Now start pointer is pointing to pivot. So the value of start pointer and pivot is same. So what you do, you increment the start pointer. Now start pointer is pointing at 6, end pointer is here. Now again, what you do, compare the value of start pointer and pivot. If the value is less, then what you do, increment start pointer. But right now the value is not less because 6 is greater than 5. That is start pointer value is greater than pivot. So you freeze the pointer, right? That means no more increment will be done on start pointer. Now look at is the end pointer, right? Now end pointer, what we do, we check whether it is greater than the pivot value. Now 7 is greater than 5. So what you do, decrement end pointer. Now what, end pointer is pointing at 9. So 9 is greater than pivot. That is 9 is greater than 5. So again, decrement end pointer. Now end pointer is pointing at 6. Again, check end pointer, that is 6 is greater than 5. So again, decrement end pointer. Now end pointer is pointing at 5, right? And S is pointing at 6. Now end pointer is already pointing at the pivot. And we know whenever this start pointer is greater than end pointer, then you swap the value of the pivot and end pointer. Now end pointer and pivot value is same. So there is no swapping. That means 5 is already at its right position. That means 5 is sorted. Now you'll be sorting 6, 9, and 7. Right? Now this is the sub array what we'll be sorting. So again, we know the very first item of this sub array, that is 6, we take it as pivot with the start pointer pointing to pivot and the end pointer pointing to the last item of this sub array, that is 7. Again, the same concept. Pivot value and start pointer value is same. So just increment value of start. Right? So start pointer will point at 9 now. Fine. Now again, check whether the value of start pointer is less than pivot. No. Right? It is not less than pivot. 9 is greater than 6. So start pointer will be freezed now. No more increment will be there for the start pointer. Fine. Now look at the end pointer. Now what you do, you check whether 7 is greater than 6. Right? 7 is greater than 6. So what you do, you decrement the end pointer. 7 is greater than 6. That is 7 is greater than pivot. So you decrement the end pointer. So now end pointer and start pointer both are pointing at 9. Now again you check end pointer data is greater than pivot. 9 is greater than 6. Condition is true. So what you do? Again decrement end pointer. So now end pointer is pointing at 6. End pointer is pointing at 6. Now you check start pointer is greater than end pointer and end pointer is pointing to the pivot value itself. So there is no swapping and the 6 is already at its right position. Fine. 6 is already at its right position. Now the next partition of the array will be sorting is 9 and 7. Right. So this red color indicates the items which are already sorted. Blue colors indicate these are the sub item or sub list which we need to sort. Now again, take the first item as pivot. 9 is your pivot with the start pointing to pivot and end pointer pointing to the last item of the sub array. Fine. Again, the start and the pivot value is same. So you increment start pointer by 1. So now start pointer is also pointing at 7. End pointer is also pointing at 7. Right. Now what you check whether 7 is greater than 9. No. So you freeze end pointer also here and start pointer is also freezed here. So now when end pointer will be swapped, we will be swapping the value of end pointer and the pivot. So 7 and 9 will be swapped. So our array is now sorted. It's a simple algorithm for applying quick sort on a list of numbers or the list of items or elements. I hope the concept is clear. What we did, we kept on partitioning the array. See, this is the first partition. This is P1, this is P2. Then we positioned 3 at its right place, right? So again, the partition is 2 and this side. But 2 is a single item, so there's no more partition. Then we selected 5, right? And this, so 5 is 1 and this whole item is 1. So again, 6 and whole item is 1. Right? So we kept on partitioning the array till we got the solution. So this is nothing but divide and conquer approach to sort the items using quicksort algorithm. Now let's look at the complexity. Quicksort's worst case complexity is big of n square is observed when the input to be sorted is in decreasing order or increasing order. If the first element is the pivot element, this is what we faced here. When we started with 5, 6, right? These two gave us the same thing, right? There was no swapping. The reason for this worst case performance is that after partitioning, one partition will be of size 1 and the other will be of size n minus 1. So the time function will be that is T of n is equal to T of n minus 1 plus big O of n, which is nothing but big O of n square. But the average performance is big O of n log n. This average performance is possible provided you select a pivot element using a proper algorithm, right? Because everything depends on the position of the pivot element. Fine. Now here are some examples I want you to try. Apply quicksort to this data and also apply quicksort to this data. Fine. I hope you'll practice them. If you have any difficulty, you can put a message, you can text me, you can mail me, or you can put it in the comment box also. Thank you. Stay home, stay safe.